Hello. There we are. Okay. Wonderful, wonderful. So today we are working on polishing and finishing out this one little game. With I'm in a university program and we have a game development club, and they are working on some games that I've been pitching in. And this particular one is about a little sheep that's trying to go to sleep and it's having nightmares or something. And so this is like a dream sequence where it's just jumping on clouds, and it's a fun little time. And there you go. There's all the sheep bounces, and oh no, he can get hurt by monsters and stuff. So there's a little bit of debugging that we're doing because not everything is working quite right. Like, so here's the title screen. It's a little bit of funkiness going on. And clouds are bouncing, but the sheep is not necessarily bouncing. It's like sometimes he does. Or see the jiggling. Okay, that was it. Works some of the time, which is what's weird. It's not. Yeah, it's not clear what in the way I'm invoking the squishing script is going wrong. I really love the art for this game. I did not make it, but it is adorable. And today, for the next hour, what we're going to work on is getting the monsters to, instead of just disappearing right when you stomp on them, we want them to actually squish a little bit and then kind of explode. So here's how we'll go and do that. We are missing some functionality. Prefabs. The project structure is a little bit messy. I'm not the one who actually put it together. Here we go. Here's our monster. And there's a whole bunch of stuff going on here, but the important thing is this monster movement script. I think that's where we're going to, yeah, we're going to implement the state there. So at the moment, the monster has no awareness of if it's dead or not. So we're going to have to make instance members for keeping track of, what do you call them? Wait, I'm not used to thinking out loud. This is interesting. So basically, this monster can be dead. And by default, it's not dead. We do want it to have an accessor. So an accessor is kind of like a getter, setter in other languages. It lets us sort of encapsulate the state of the monster, making it accessible to outside observers, but not making it so that other people can mess with state directly. So it sort of lets the state be examined, but doesn't let it be mutated. It's a little bit overly verbose. I don't love that about properties in C#, but it's okay. So there is some stuff. This is also an editor script, which is a little bit weird. Yeah, some of the coding decisions Like the way that we keep track of the direction of this monster is a little strange. If I refactor this, I'm not quite sure what I would do. But effectively, all we have to do to start is to start having the death state affect this is we just add a check for it. So if the monster isn't dead, then animate normally. Otherwise, the monster is dead. Yeah. Otherwise, the monster is dead. I don't think we want to put anything here right away. So I'm thinking that, this game is using a lot of squash and stretch. I would like our little guy to sort of when he gets stomped on. Oh, what would you call it? This is an excellent chance to use my drawing tablet, maybe. Let me just see if it's working. Perfect. Okay. So check this out. We are going to switch over our stream. Oh. Nope. Nope. There we go. Okay. This is OneNote. Not great for art, but it is good for like demos. So basically we have these monsters and they're shaped kind of like this, and there's this little dude who's coming down. Monster's gonna be hit on the head, and we want them to squash in, but then squash out like that. And then I think at the end maybe like a freeze, like a half-second freeze, or just like whoa. Yeah, so this is going to take some interpolation. We're going to do a little bit with event handling. Back to the other thing. Let me. That work? Maybe. Not sure. Nope, it didn't. There we are. Okay. So, let's see. A couple things are going to be happening here. I need those. Yeah, no. Other thing is sometimes other people mess around with this code and there's some residual artifacting that isn't totally cleaned up. One of the things about working in a team, especially when a lot of people don't, they're students, they don't quite know what they're doing, you can get miscommunication about what is trying to happen where. But yeah, so in C# there's these things called delegates, which you can. This isn't quite what they are. I don't honestly completely understand what they are, but basically a delegate is sort of like a container that you can attach callbacks to, and then if you invoke the delegate, all of those callbacks get invoked. And the one restriction on the things you attach to a delegate is they have to have the same sort of method signature or set of parameters and return type as the delegate itself. So we're going to do a couple things. These are all going to be public because delegates are their way for implementing the subscriber pattern, which is we want to let other people subscribe to these events and see when they happen. Public delegate void, monster died. Oh, killed. That's better. We're not going to take any parameters. That's fine. Public delegate void. The other thing that's going to happen is we're going to animate the death. So monster death animation started. Public delegate void monster death animation ended. Okay, so these are delegates. And now we actually have to make instances of them that belong uniquely to this class. So when we instantiate the monster, in turn going to instantiate its own version of these delegates. So, you know, it's kind of like just a regular class, except that instead of being called a class, it's called a delegate. So public monster killed, and then the convention here is like when something has happened. So on monster killed, and it's just a field. We don't need the parentheses because it's a field. Public on monster death. Whoop, can't type today. Animation. Whoa, started, and I forgot my type. Monster death animation. Start. There we go. On monster death animation. These are long, and in my opinion, it's better to be verbose than not to be verbose. Monster death. On monster. Oh, that helps. Sometimes Visual Studio has some nice autocomplete features. So now we've got those. Now what we have to do is we have to set up the event triggers in code for when these events should be called. And then we're also going to write some event handlers. So the way this project is currently architected, the monster can't tell that it's been killed. It's killed by the player, so the player owns that. And so we're gonna, to handle that, we're gonna make a public method exposing part of the state. So public void trigger kill. There we go. And what this will do is, you know, if another instance calls this, like the player jumps on my head and kills me, this is how they're gonna communicate that I've been killed. What you do is you take on monster killed. You're gonna use something called null propagation. Because if a delegate has nothing attached to it and you try to invoke it, you get like a null reference exception. So the question mark lets us check to make sure that nothing is null. And then we just say invoke. It's going to go through and call everything that's attached to it. The other thing we want to do, and this is sort of under the hood, is trigger this one on monster death animation started. And I don't actually know if we'll use that yet, but and we might use it for like a particle system at some point. And then the final thing is you want to do, so those are our event triggers, but we also need to do our state update. So we're going to say, before we trigger the events, is dead is now true. The monster is now dead. Yeah. Okay, so now what we need to say is that there's a if the monster is dead and it's not destroyed yet, then we can assume that it's in the process of animating its death. So this should maybe be pulled out into its own function. Not quite sure yet. And you know, if you remember that little picture we had before of let me see. Can I do it? Did that do it? Nope. Did that do it? Yeah, there we go. Okay, this little picture, we need to store some information about how far we want the squish to happen. I'm thinking we take 50% off the top and stretch by 50% to preserve the volume, I think. I don't remember quite. I think volume might actually be quadratic, but we just have to do something that looks convincing, not something that's accurate. So, about that. Did that work? Yes, that worked. Okay, so up here, we're going to have this stuff we can actually serialize. We can expose this to the player. Serialized field. I'll call it death squash scale. So vector 2. Let's do it as a. Well, no, vector. So this is a 2D game. We'll keep it 2D. We call this death squash relative scale. And then in editor, we're gonna set that to, you know, like positive 0.5, negative 0.5, something like that. Down here, we also need to cache the original. Did we cache the original transform? Cache the original position. Yeah. So I'm going to call it up here. So you need a vector 3 for original scale, because we need to be able to define the relative scale in relation to everything else. So we go here. And then when we trigger the kill, we're going to cache that scale. Like that. And then down here, here's what we do. We have a condition. We say, if our current scale is not equal to, and this is where it gets a little confusing. Gonna make a variable vector 3 target scale, and this is just going to be our the original scale multiplied by that what is it called? Death squash. Like that. And because of the way Unity, the structs for vector 2s and vector 3s handle, we can multiply a vector 2 by a vector 3 and get a vector 3 back. That's nice. Let me make that. So if the, whoa, sorry about that. Windows is strange. There's all sorts of weird crap in Windows these days. Well, right, target scale. If the local scale is not the target scale, then we do our animation. And for now, I think we're just going to do a really simple lerp. So I don't want to do that. We'll do it the dumb way, and we'll expose it. This is not the best way to do tweening. In other parts of this game, this isn't how we do tweening, but since we're in a little bit of a rush, and it's not really going to matter that much, we do. We're gonna call it scaling or factor. We'll keep it relevant to depth. So depth scaling or. And we're going to default it to 0.8. We want it to happen fast. And then the only other thing is we're going to have that hold at the end of the animation. So when the squash finishes, we're going to hold for like half a second. That's a car alarm, I'm sorry. So we're gonna call that the hold time. And set that to 0.5, just a full half second. Okay. And then when you're keeping track of something like that, we're going to call it, we need an internal variable called death hold start time. And we could do the coroutine. I kind of prefer it this way because coroutines, here you end up with a lot of variables. Coroutines are a little screwy because of these big, long method groups, which, you know, I think you could argue for it either way, but I'm more familiar with this. And we're not even going to define that. This one is uninitialized. So, and we go down here, and so this is where, you know, we're gonna lerp lerp stands for linear interpolation, so it just takes you from point A to point B at a constant speed, more or less. But the way we're implementing it, it's going to look quadratic. Quadratic means it starts slow, starts fast, ends in the middle. No, not even quadratic. It's going to ease in and then quickly go out, something like that. You'll see in a moment. Yeah, so if the local scale is now equal to the target scale, and oh, I've set myself up here for some difficulty. So this is maybe too many fields. So we're gonna go back and refactor later, maybe. We're okay for now. Death hold start time, and then I'm gonna use a Boolean. Is death holding? And by default, no, we're not. By the time that sets to true, if not, is death holding at and transform. So otherwise, so if the hold hasn't triggered yet, we catch that here, and we set the death hold start time, time, just like that. That's it. And the final handler for the conditional is we do a check. We say, well, actually, we're not there yet. So we have one more. So now we say if the current time minus the beginning of the hold is less than, so if the duration is less than Death animation the whole time. Yeah. You know, I'm gonna call that, just to make that a little more clear, I'm gonna call it death hold duration. We're gonna jump up here, right here. Death hold. Now we sort of have this semantically grouped set of properties that correspond to that. And since we're actually just freezing, we don't need to do anything here. So in fact, we're gonna skip this. We're gonna say if the duration is expired, if the duration is now greater than what was prescribed, then we need to trigger an event. So on monster death animation ended, null propagation, invoke. That. Yeah, and that's it. So let's just put that lerp in, and then we can test this. And then we have to hook it up to the player, but we can almost test this. So the way you lerp in a way that's kind of an ease in, quick out sort of way is you just take the value that you want. So transform.local scale, and then you set it equal to itself, but lerp. So like this, transform.local scale. And then we're lerping towards target scale, and then we just plug in the death squash, death scaling lerp factor, that, just like that. And that's it, and that'll move us towards what the player defined as the final relative transform scaling. Did we set death holding to true? We did not. Forgot that. If we hadn't done this, wouldn't have worked. Would have just kept repeating. Okay, so that's it for the monster, basically. The only thing we want to do is make a handler for the end of the death animation, because when it stops, handle death animation ended. When the animation ends, that's when we actually destroy the monster. So we destroy this guy's game object. And I guess we don't need this, but it sort of makes clear that, you know, that's what we're going for. And if we wanted to, here we could put in the spawn for like a particle system. But for now, we're fine. Now the only thing you have to do is, here's the first example of hooking stuff up. So when you're connecting events, or like signals, I guess, private, disable. Now why are they blue? Oh, because they're Unity. Okay, yeah, got you. These are like callbacks specific to Unity. So when the instance is enabled, you want to add the connections. When it's disabled, you want to take away the connections, because if we don't do that, we could get memory leaks if the connections start to build up. So the only one in here that we need to make a connection to it in the monster is the ending animation. And all we do is we hook up that callback, the handling death callback. Don't include the invoke. We would just want the function pointer, not the actual result of the function. If you put the invoke, then it will automatically, the monster will just destroy itself on enable, which is not what we want. Okay, so we do that, but now what we add, we need to then clean up later. When we disable, we just take away the connection. Like that. All right, let's check Unity for compiler errors. I think we're fine. Actually, we shouldn't just check for compiler errors. We should also update the prefab. The relative squash, we're gonna make it teeny tiny. Well, we're gonna make it very wide. We're gonna extend it to like 1.4 times its original width, and then we're going to make it tiny 0. You know, maybe we almost honestly let's crank. It's always nice to go a little exaggerated and then crank back down after the fact. I feel like half a second's gonna be a little long. 0.4. Okay, but now, even though this is all hooked up right, we have nothing gonna actually kill the monster. So we need something to do this, the trigger kill. So notice this class is named as if the person was writing in Python, which is unfortunate. Because a lot of students, they come into this club having just only done Python. So basically, it's a very long, messy behavior. We don't have to worry about too much. You can see we have our own dev handlers here. This is nice. And what are we looking for? Okay, here we go. This is where this stuff happens with the monster. Oh, is there not? Wait. Let me look. Okay, yeah, never mind. Yeah. All right. No, now I've lost my position. So here, right here, this is like a fancy way of saying if we collide with the monster but we're underneath it, we should get hurt. The first thing we need to do is say if the monster isn't dead, get hurt. So we're gonna go collision, game object. Component monster movement. There's a chance, because of the way we're doing this, that there won't be a monster component, so we're gonna do null propagation. And then we get the is dead tag. And we don't want it to be dead. We only want ourselves to get hurt. Uh-oh, what's wrong? Ooh. Yeah, the bull. Okay. Yeah. A little tricky to explain, but we're gonna get rid of that question mark for now. This could be a null reference error, which is unfortunate, but if that happens, that's kind of a problem with. There really should be like an interface, a monster interface with common properties to every monster, but there's only one kind of monster in this game. This is fine. We jumped on the monster. Yeah, all this happened. There's one other thing I want to do, which is if the monster is dead, we want to disable its collider. It's important. Trigger kill. Where did we put that? Do I have a rigid body? Or B? No, I don't. Okay, so get component rigid body 2D. Oh. To get attached colliders. Okay, this is where Unity is a little annoying. You can't just disable collision on a whole instance. We have to do it in a somewhat roundabout way. So we hash the component, and we say you have to go through each collider manually. And RB. Nope. And it's also weird, you have to set up an array. So we say collider 2D, colliders, collider 2D, but the length of the array you have to pre-specify using collider no get. Where was that? Is it not there? Weird. There used to be a property called collider count. Ooh, there we go. That's our guy. Attached. And I have the wrong type here. There we go. So now what we have to do, now that we've initialized that, this is so roundabout. In the 3D rigid body, you can just disable all collision. Can't do that here. Colliders. Nope. RB.get attached colliders, and we pass it the reference that we just made. Now, finally, we take each of those colliders. There's only one, which is why this is even stupider. So for each collider inside of colliders, we set it to. I want to make sure I'm doing the right one. I think we just do enabled. That one. Oh, yeah, okay. You disable it. And this is complicated enough. I'm going to make a void private method called set collider state, set collider active. Go. And we're going to do bool. Is it active or not? Take all this right here and just gonna call it is active. And this should really be, you should not have to write code like this. It's annoying. Anyway, to disable collision. But so what we do is we say set collider active to false. Now the player can't collide. Okay, back to player stuff. So if the collision object isn't dead, hurt the player. We can assume that if we're colliding. I'm not going to put a check for whether or not it's dead. This line right here, destroy collision game object, we instead say abstract that out. A monster trigger kill. Cool. And over here we say if monster isn't dead. Got sort of on the fly refactoring. And that's it. That should be it. It's not it because it's never it. But we are about to see if anything happens. Let's test it. So where is my mouse? No. Wrong window. Okay, so now we go back to the main scene and we just play, and hopefully there's no compiler errors. There's our guy. All right, we're gonna jump on him. Oh, it did it! Yay! It worked on the first try. That's rare. Oh. Now what we need to check is there is no rigid body attached to. Oh, there's what? There's no. I see. Yeah, these monsters don't actually have physics enabled. So there is a tiny error, but it's not breaking anything. And that's to say that we can't check the rigid body for colliders. It could be the better way. This is nice. It's nice that we abstracted everything out. Where did we put it? All the way up here, somewhere. Yeah. No. Okay, I'm looking at the wrong script. Is that collider active? So, you know, all of this. I'm gonna comment that out just for now. Oh no, do I not have? Yeah, I don't know how to comment. I'm in a German keyboard. Don't ask why. Control question mark does not work here. We are gonna say is this is much simpler to query actually. We just say get components of type slider 2D. And now we're good. That should have the same effect and the error should go away. But, yep, no more errors. Ooh. 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 What I am gonna do is reduce that hold time. These guys in here, the death hold can probably be much shorter. And the lerp factor, take that down slightly. Oh no! Rupp. Ooh, still a little bit long, isn't it? What? Oh, yeah. Okay, let's experiment with that. Oh no, that's a bug. It's too high to jump to. All right. This could be a bug. Let's make the duration 0. See if there's no hold when it's set to 0, it's working properly. Interesting. Okay. Yeah, part of that is yeah, what's going on there is the lerp isn't quite right. So we need to make a check. This right here. Can I divide a vector? I don't think I can divide a vector by a vector. Let's do it this way. Magnitude divided by target scale. So we're gonna take the relative. So the local scale is a percentage of they need to be close to 1. So if it is, we're gonna do it this way. It's getting a little fucky, but math f absolute value of 1 minus the current percentage. We need to be very close, so like 0. Like that. What this is saying is the percent, it needs to be sufficient, the scale that we currently have needs to be sufficiently similar to the target scale so that we can say that there's less than a 6% variance in it. And I need to actually invert that sign. We want the lerping to happen so long as this is here. Yeah. Okay. Now we get to check. Whoa. Insta death. That's not so good. No, why is that hard to jump? Ah, there we go. Now it works. Yeah, vector comparison is a little screwy. I kind of like it without a hold, but let's see what happens with the hold. So we're gonna make the hold for 350 milliseconds, which is about the length of time it takes for a human to like. Okay, that's better. I like that. Ah, I don't know. But yeah, now the monsters are squishy. Boing. Boing. And we could even, honestly, make it even faster. And jump. Yeah, that's nice. Boop. What do you think? Oh, and I died. That's it. I mean, that's the entirety of the feature implementation, basically, and I think we did it in just about an hour. So, thank you for watching. It was fun. I'm gonna put this into source control in a moment, which I don't think I need to show. It's a little bit boring, but yeah. Okay, it's a fun little game. Again, I love the art. The art is adorable, and I'm hoping with the squash and stretch to make those things more adorable. So, anyways, goodbye, so long, farewell, thanks.